Alright, good day everyone. So today we will be talking about number systems. Now, the objectives of this is to understand why binary numbers are used in computers, to know how to convert a certain number system into binary, which is base 2, octal, which is base 8, decimal, which is base 10, and hexadecimal, which is base 16. So here are some following number systems. No, it includes binary. So again, binary is base 2. We also have octal, which is base 8. We have decimal, which is base 10, and hexadecimal, which is base 16. Now, what's the purpose? Why do we need to study, or why do we need to use binary system? As we all know, computers are made of series of switches. It means that the states of the switches has only on and off, or ones and zeros. So on is represented by 1, while off is represented by 0. Okay, what is a binary number system? Most modern computer system uses binary logic. The computer represent values 0 and 1 using two voltage levels, usually 0 volts for logic 0, and if 1, that's either 3.3 volts or 5 volts. The binary number system uses base number 2. Okay, now we will be talking about in this video the conversion from binary to decimal only. No, so other number system conversions will be we will be having that in a separate video. So let's say, for example, 101 base 2 to be converted to decimal, which is base 10. Okay, remember that ones and zeros are binaries, right? So 101 here is a binary. Okay, and also you can see that the base is 2. So if you can see, guys, that 2120 2, so this is not a binary. No, there's no such thing. So you are going to leave that. You are going to mark that X, or you can say that this is not a binary number. Okay, now we will be converting 101 to base 10. So that's easy. Okay, so in binary, there are corresponding values. Starting with 1, 2, 4, 8, 16, 32, 64, and so on and so forth. So here, we have 101, so that's 101. We start with the left. Okay, now we will be adding values which is turned on or has the values of 1, which means 4 and 1 are turned on, diba? So 4 and 1 are turned on. So which means that we will be adding 4 and 1. That will be 5, right? So 4 plus 1 is equal to 5, which means that our final answer for number 101 base 2 is equal to 5 decimal. Do not forget to put the bases. Okay, let's have a rule: no base, no score. This is your final answer. Please box that. Wait, okay, wait. Okay, now for number 2, 010101. The same thing po. Okay, so again, you write the values 1, 2, 4, 8, 16, 32, 64, 128, 256, and so on and so forth. Let's see if magkasya. So 1, 0, 1, 1, 0, 1, 0. Alright. So once again, we will be adding numbers that are turned on. So meaning the numbers which are on state 1. Alright. So starting off with 32 plus 8 plus 4 plus 1. Okay, so which means that this is 40, 44, 45. So therefore, your final answer would be 0101101 base 2 is equal to 45, sorry, this would be base 10. 45 base 10. Now, do not forget to box your final answer. Okay. Now for number 3. 11101 base 2 to decimal. Okay. So same thing. So 1, 2, 4, 8, 16, 32. Okay? 1, 0, 1, 1, 1. So disregard na po natin si 32. Once again, we will be adding numbers which are on state on. So 16 plus 8 plus 4 plus 1. That would be equal to 24 plus 4, 28 plus 1. That's 29. Therefore, your final answer here is 11101 base 2 is equivalent to 29 base 10, and this is your final answer. Okay. Now, what if vice versa? We will be having conversion from binary or from decimal to binary. So, conversion from decimal to binary. Okay, take note that decimal is base 10, okay? So, example, decimal, for example, let's have the basic one first. 23 decimal, convert it to binary. Okay, so here we can say that 23 is a decimal. Okay. Now how do we solve this one? We have two ways. Now the first way is like this. The first method, method 1. You will be dividing 23 until it becomes 0. So this one would be 23 divided by 2. That would be, hold on, let me use calculator. By 2. Okay, that's 11. So quotient, remainder. That's 11 and remainder is 0.5 times 2. So that is 1. So 11 divided by 2. That's 5.5. So 5.5 times 2. That would be 1 once again. 5 divided by 2. That's 2. 0.5 times 2. That is 1. Then 2 over 2. That's 1. Remainder 0. Times 2. That's 0. Then 1 divided by 2, 0. So you will stop here, no? We will be stopping here since the quotient reached 0. Okay? So 1 divided by 2, that's 0. Then remainder is 0.5. Then you will be having 1 here. And then the final answer would be, okay, so upward. So the arrows, the arrow will be upward, which means that we'll be starting to get the value here from the bottom to the top. So that's 1 or 2310 or decimal is equivalent to 10111 binary. This is your final answer. Okay, let's check if it's correct. 1, 2, 4. So 1 plus 2. So 1, 2, 4, 8, 16. We will be adding the numbers with the on state or the state na 1. So 16 plus 4, 20 plus 2, 22 plus 1, 23, which means this is correct. Okay? Alright, now for method number 2, method number 2 is just the same with what we did in method number 1. The thing is that you will write numbers 1, 2, 4, 8, 16, 32. So, since 32 is not, sumobra na po siya sa 23, so, i-erase na natin siya. No? We do not need 32. What we need here is, we will be looking for numbers from 16, 8, 4, 2, and 1 that will suffice or that will come up with the number 23. So, which means that if we turn on 16, so ang natitira na lang po na numbers is 7. But 16 plus 7 is 23. Which means that you will be turning on this 3 right here. So, therefore, that's 16 plus 4, 20 plus 2, 22 plus 1, 23. Now, this is your final answer. Okay? So, kayo po bahala which method you will use. Either you will use divided by 2 or you will use the second method here. Okay? Now, the problem is, with method number 1, what would happen if we have the value 2,000 or, sige, wag muna 2,000, like 256 or 258. Sige, let's make it higher. 363 base 10. That's decimal to binary. Alright. So here, instead of using method 1, which will take us a long way, because you will be dividing 363 divided 2, then the product of the quotient of that will be divided by 2 as well. I'll be using method 2. Okay, why? Look. 1, 2, 4, 8, 16, 32, 64. Oops, di siya magkasya. Wait. Sige, 1, 2, 4, 8, 16, 32, 64, 128, 256. Hindi na pwede 512, no? So, you will be turning on 256. So, 363 minus 256, kulang po tayo ng 107. So, kung 107 ang kulang, you will be turning 128 off. Then, i-on natin si 64. So, 107 minus 64, 43 na lang. So, 43, turn on natin si 32. So, 43 minus 32, 11 na lang. Okay? So, since 11 ang kulang, i-zero natin si 16. And then, i-1 natin si 8. So, minus 8. 3 na lang po yung kulang, which means i-off natin si 4, i-on natin si 2 and 1. Which make it our final answer. There. Okay? So, kahit umabot na po siya ng 2,000 or 3,000, I think method 2 is simpler than method 1 because the greater the number in decimal is, the harder or the longer the process will be. So that's it for today's lecture. Thank you so much for watching this video. Have a good day.